Assalamu alaikum. Hello everyone. Welcome to our another video. Today we'll discuss about the Stackelberg competition model which we have taught in the graduation level. Uh, my name is Rakibul Islam Rakib, and I am a master's student in SAST, and along with my friend, please
Uh,
introduce yourself.
uh,
Yeah.
my name is Rajaul Purin, and my MSS registration number is 2022-1021. Okay, let's start, Rakib.
And yes, please begin. Consider the question is about the Stickelberg model, and here give that question demand curve, inverse demand curve function, which is P of Q is equal to 10 minus Q, where Q is equal to the farm 1 plus farm 2 output, aggregate output. And in addition, consider that farms are cost symmetric, facing a common marginal cost of MC is equal to 4 for every farm, which means farm 1 and farm 2, and no fixed cost. So first question is the find the Stackelberg output each farm produces in equilibrium. As we have already known that, or you should have known that the Stackelberg model, there is always a follower and a leader. There is always a last mover or uh, follower. Uh, Here if we comes to the solution, here farm two, here as farm two as the follower. So we'll find out the profit maximization problem of farm two first. Farm 2 chooses output Q2 that solves the following profit maximization problem, which is maximum pi 2 is equal to PQ into output of farm 2 and total cost of farm 2. And then taking the first order condition with respect to Q2 or farm 2 and assuming an interior solution for Q2, which is 6 minus Q1 minus 2Q1 is equal to 0, where Q1 is always greater than 0. After rearranging the best response function of the farm 2 in response to farm 1 is given. So from the above equation, if we derive the equation in terms of Q2 is equal to 3 minus Q1 by 2. And the last mover or leader, farm 1, anticipating that farm 2 will respond with the best response function, chooses its output on level of Q2. That derives after the farm 2, the farm 1 will respond. That solves the following profit maximization problem, which is maximum pi 1 is equal to PQ1 and total cost of Q1. So in the next slide, in the same procedure, taking the first order condition with respect to Q1, and we can find the optimal output of farm 1 becomes Q1 is equal to 3. And finding the equilibrium output for the follower, substituting the optimal output of farm 1 into farm 2's best response function, the farm 2's optimal output becomes Q2 is equal to 3 by 2. So in the next slide, the question number 2 begins. And please, Rajal Karim Jewel, take the floor.
Okay, thank you, Rakibul Haidar. You well explained in problem A. Now I will discuss problem B, where consider now that farm to invest in a cost-saving technology which transform its cost function to total cost Q2 equal to Q2. So that is marginal cost now decreased to find equilibrium in this Stackelberg game. How are your results are one affected. Okay, the solution in part problem B. First of all, we find out the profit maximization in farm 2, which one is follower, and maximum pi 2 q2 equal p of q and q2 minus total cost of q2, and we the result 8 minus q1 minus q2 of q2, and this equation the first order condition with respect to q2, and after rearranging the equation, we find the result of farm 2 in response of farm 1 is given by q2 of q1 equal 4 minus q1 by 2. Please next slide. And similarly, we finding the farm 2 best response function where farm 1 the best response function, which one is leader, and where q2 equal q1 equal 2 minus q1 by 2 by of q1, and this equation with first order condition with respect to q1, and assuming in the solution of q1 equal to 2, and this q1 result we substituting the optimal farm 1 into farm 2, then the optimal output of farm 2 becomes q2 star equal 4 minus 2 by 2 equal 3. So we say that when it is less expensive for farm 2 to produce the output, farm 2 doubles production from 1.5 to 3 units. Problem A, where we found the production 1.5. So it is we say that it's increasing, and same farm 1 reduces output to 2 units, which now falls below that of farm 2. Okay. Our next problem is C. Please, Rakibul Haidar, explain this problem.
So here the question is repeat parts 1 and B, but assuming that farm 2 is the industry leader and farm 1 is the follower, which means there is a shuffle between farm and leader and follower, and from the very own process or very backward process we have done in the part 1 and part B. In the same procedure, we can solve this problem of C. As farm 1 as a follower, and the following profit maximization problems for farm 1 is max pi 1 is equal to PQ1 minus total cost. Here we find the maximum profit maximization problem, and taking the first order with respect to Q1, we can find the best response function of farm 1 is equal to 3 minus Q2 by 2, and in the same procedure farm 2 first mover as the leader, anticipating that the farm 1 will respond with best response function of Q1, which is in the first part we derive it. Q1 is equal to 3 minus Q2 by 2, chooses its own output level Q2 that solves the following profit maximization problem of pi 2, and here the optimal output of farm 1 becomes Q2 is equal to 5. Finding the equilibrium output for the follower, substituting the optimal output of farm 2 into farm 1's best response function, the optimal output of farm 1 becomes 1 by 2. Therefore, in that case, that the leading farm invests in cost-saving technology, farm 2 produces 5 units of output, while the farm 1 produces half unit of output. And here comes the next questions. Please, Joel, Rajal Karim Joel,
Yeah.
explain it.
Thank you, Rakib Haidar. Our last problem in this D, where assume now that a new farm 3 joins the industry, and acting last after farm 2 chooses its output. Cost saving technology is a common knowledge, and marginal cost equal to 2. Find out the equilibrium of this Stackelberg gap. Okay. Now new scenario of farm 3, who is the following profit maximization problem is pi 3 of q3 equal p of q3 minus total cost
So Joel, which farm is the last mover?
is the last mover is the farm 3. Uh,
So as the farm three is the last mover, we
mover.
have to derive the farm three as fast.
Yes.
Yes,
And
let's continue.
this farm 3 profit maximization finding 8 minus q1 minus q2 minus q3 of q3, and this equation first order condition with respect to q3, and finally we find the best response function of farm 3 is q3 equal to 4 minus q1 plus q2 by 2, and second mover is farm 2, and the second mover farm 2 anticipating that farm 3 will respond with its best response function, uh, and solving the best response function in the q2. Please next slide. Where 4 minus q1 plus q2 by 2 into q2, and the finding the this equation the first
And
order
taking the first
product
condition.
condition, yes,
Yes, yes.
q2, and then finally we finding the best response function of farm 2 in response to farm 1 is q2 of q1 equal 4 minus q1 by 2, and similarly the best response function of q3 can be written in the putting the q2 uh, q2 form, q3 equal 2 minus q1 by 4, and finally farm 1, which one the first mover, farm 1 anticipating that farm 2 and 3 will respond with their best response function q2 equal to 4 minus q1 by 2 and q3 equal to 2 minus q1 by 4, and respectively chose its own output level q1. The solve the following profit maximization problem: pi 1 equal p of q1 minus total cost of q1, and the result is 2 minus q1 by 4 of q1, and this equation first order condition with respect to q1, and finally we finding the optimal output of farm 1 becomes q1 equal to 4. Okay. Finding the equilibrium output in the third mover, and substituting the optimal output of farm 1 into farm 2, best response function is q2 equal to 2. Similarly substituting the farm 3, where q3 equal to, please, q3 equal to
1.
1, yes, maybe is the correct correction, please. Q3 maybe, yes,
Yeah.
q3 equal to 1.
Q3, it's Q3 is equal to 1. Yes, you
Therefore,
are
when
correctly said.
all farms face the same cost, farm 1 and 2 continue to produce 4 and 2 units of output respectively, while farm 3 produces 1 unit of output. This is the
Thank you, Joel. You beautifully explained the questions, and it is easily understandable. And here ends the our this problem. So thank you everyone for listening us. Stay tuned with us.
thank you everyone. Assalamu alaikum.